Good morning. Today we can start new chapter feedback amplifiers and oscillators. Feedback amplifiers and oscillators. Okay. So in this chapter we discuss about introduction, concept of feedback, positive feedback, negative feedback. Okay. Next, objectives of this presentation. On completion of this period, you would be able to understand the introduction and the concept of feedback and positive feedback and negative feedback and also summary. These topics discussing one by one now. Okay. First of all, introduction. So, introduction to feedback amplifiers and also oscillators. First of all, feedback amplifiers. So, feedback plays a very important role in electronic circuits, and the basic parameters such as input impedance, output impedance, current gain or voltage gain and bandwidth. Okay. So, feedback plays a very important role in electronic circuits, and the basic components or basic parameters such as basic parameters of feedback is input impedance, output impedance, voltage gain, current gain and bandwidth. Okay. In case of large signal amplifiers and also electronic measuring instruments, the major problem of distortion should be avoided as far as possible. So again, the gain must be independent of external factors such as variation in the voltage of DC supply and the values of the circuit components. I repeat this point again. In case of large signal amplifiers and electronic measuring instruments, the major problem of distortion should be avoided as far as possible. Again, the gain must be independent of external factors such as variation in the voltage of DC supply and the values of the circuit components. Okay. All this can be achieved by feedback. This feedback is of many types. Feedback is of many types, but the two prominent methods of feedback are positive feedback and negative feedback. So, all this can be achieved by feedback. This feedback is of many types. Feedback has many types, but the two prominent methods of feedback are positive feedback and negative feedback. In this chapter, we will discuss the concept of positive feedback and negative feedback. So, this is nothing but the introduction of feedback amplifiers. Feedback. Okay. So, next, introduction of oscillators. Oscillators are widely used in radar communication systems, measuring instruments, etc. Oscillators are widely used in radar communication systems, measuring instruments, etc. So, these are also called as signal generator. These are also called as signal generator. So, which produces an output signal in the form of oscillation by taking the DC power supply. Okay. I repeat this point. Oscillators are widely used in radar communication systems and measuring instruments, etc. So, oscillators are also called as signal generator, which produces an output signal in the form of oscillation by taking the DC power supply. It means that oscillators produces output signal without any input. It means that oscillators produces output signal without any input. These oscillations are produced by using positive feedback. These oscillations are produced by using positive feedback. Okay. This is nothing but introduction of feedback and oscillators. Okay. Then goes to next topic. Next topic is concept of feedback. Concept of feedback. So first of all, what is the definition of feedback? The process of adding some fraction of output energy. Output energy means either voltage or current. Output energy of the device to the input is known as feedback. I repeat once again the definition. The process of adding some fraction of output energy of the device to the input is known as feedback. The process of or another definition. Another definition of feedback is nothing but the process of taking a fraction of output signal. The process of taking a fraction of output signal and feeding it back to the input circuit is known as feedback. The process of taking a fraction of output signal and feeding it back to the input circuit is known as feedback. Okay, this is the definition of feedback. So you can select any one of definition. You can select any one of definition. Okay. Next, concept of feedback. Concept of feedback. Okay. So this is the figure of concept of feedback. This is the figure of concept of feedback. A typical feedback connection is shown in figure above. So see this figure. So this figure consists of two blocks: basic amplifier. The gain of basic amplifier is capital A. Feedback network. So feedback network factor is beta. Beta is nothing but feedback factor. Okay. And one mixer. And one mixer. Okay. So these are the basic components or basic blocks of feedback concept. Okay. This is the figure. In this figure, see this. Input voltage, input signal voltage is nothing but Vin. Vin is the input signal voltage that is applied to a one input of mixer network. That is applied to a one input of mixer network where it is combined with a feedback signal Vf. Where it is combined with a feedback signal Vf. The difference of these signals, Vi and Vf. The difference of these signals, that is nothing but Vi plus or minus Vf is then output voltage to the amplifier. Then the output voltage to the amplifier. I repeat this point again. The input signal Vi is applied to a mixer network where it is combined with a feedback signal Vf. The difference of these signals Vi plus or minus Vf is then the input voltage to the amplifier. Input voltage to the amplifier. Observe this, a portion of amplifier output. Amplifier output is nothing but the V0. So a portion of the amplifier output V0 is connected to the feedback network. V0 is connected to the feedback network. Okay. So the feedback signal is applied to the input mixer network. Again this feedback signal is applied to the input mixer network and is fed into amplifier. So observe this. Vi, feedback network, output of feedback network is nothing but Vf and input of feedback network is nothing but V0. So V0 is output of basic amplifier circuit. Okay. So input of basic amplifier circuit is nothing but Vi plus or minus Vf. Okay. That is the difference signal. Okay. So next, difference signal. So depending upon whether the feedback energy, depending upon whether Vi plus or minus Vf, so depending upon whether the feedback energy aids or opposes, plus or minus, that means aids or opposes the input signal. These are two basic types of feedback in amplifiers. Okay, depending. So I repeat this point again. A portion of amplifier output V0 is connected to the feedback network. Feedback signal is applied to the input mixer network. Feedback signal is applied to the input mixer network and is fed into amplifier. What is the input of basic amplifier? Vi, that is Vi plus or minus Vf. So depending upon whether the feedback energy aids or opposes the input signal, there are two basic types of feedback in amplifiers. So that is Vi plus Vf means positive feedback. This is nothing but regenerative feedback. Vi minus Vf is negative feedback. That is nothing but degenerative feedback. So one is regenerative feedback, other one is degenerative feedback. So okay. Next, note. So feedback factor. Next one is feedback factor. So beta is nothing but feedback factor. So what is the definition of feedback factor? The ratio of output of feedback network, that is feedback voltage to the input of input of the amplifier V naught. So the ratio of output of feedback network, that is feedback voltage Vi to output of amplifier which is applied to the input of feedback network is called as feedback factor. I repeat once again the definition of feedback factor. The ratio, it is defined as the ratio of output of feedback network. What is the output of feedback network? Vf, that is voltage, feedback voltage Vf, to the output of amplifier. What is output of amplifier? V naught. What is output of amplifier? V naught, which is applied to the input of feedback network is called feedback factor. Okay, the feedback factor beta is equal output of feedback network by output of amplifier. Output of feedback network is nothing but Vf. Output of feedback amplifier is nothing but V naught. Therefore, the formula for beta, feedback network beta is, feedback factor beta is equal Vf by V naught. Vf by V naught. Okay, this is the formula. So this is nothing but concept of feedback. This is nothing but concept of feedback. Okay, next positive feedback and negative feedback. Next, positive feedback and negative feedback. So positive feedback, first of all, positive feedback. So when the feedback energy, either voltage or current, is in phase with the input signal is called positive feedback. What is the definition of positive feedback? When the feedback energy, either voltage or current, is in phase with the input signal is called positive feedback. So this is illustrated in figure A. See this figure. This is a positive feedback figure. Observe this figure. Both amplifier and feedback network. Observe this figure. Amplifier and feedback network introduces a phase shift of 180 degrees. So amplifier introduces 180 degrees phase shift and also feedback network introduces 180 degrees phase shift. Both are introduces 180 degrees phase shift. Then the resultant phase shift around the loop. So the resultant phase shift around the closed loop is nothing but 360 degrees. So that causing the feedback voltage Vf to be in phase with the input signal. Observe this waveform. So we can apply the positive going signal at the input side. So that is applied to the input of amplifier. But amplifier introduces 180 degrees phase shift. That's why the figure goes negative feedback. Positive cycle goes to negative cycle. Then it is applied to input of feedback network. So this negative signal is applied to input of feedback network. Here feedback network also introduces 180 degrees phase shift. Here feedback network also introduces 180 degrees phase shift. That's why, so negative is goes to positive. Therefore, output of feedback network is positive signal compared to this signal to the input signal. Both are same. Both are within phase. Within the phase. Both are in phase. Okay. Next, the positive feedback increasing the gain of the amplifier. The positive feedback increasing the gain of the amplifier. However, it has disadvantages of increased distortion and instability. The positive feedback increases the gain of the amplifier. However, it has the disadvantages of increased distortion and instability. Therefore, positive feedback is not used in amplifiers. Therefore, positive feedback is not used in amplifiers, but it is used in oscillators. An oscillator is a device that converts DC power into AC power of desired frequency. An oscillator is a device that converts DC power into AC power of desired frequency. This is nothing but positive feedback. Similarly, negative feedback. What is the definition of negative feedback? So when the feedback energy, either voltage or current, is out of phase with the input signal. When the feedback energy, voltage or current, is out of phase with the input signal is called negative feedback. Out of phase with the input signal is called negative feedback. See this figure. This is illustrated in figure B. See this figure. See this figure. So in this figure, the amplifier introduces a phase shift of 180 degrees into the circuit. The amplifier introduces a phase shift of 180 degrees into the circuit, while the feedback network is so designed that it introduces no phase shift, that is nothing but 0 degree phase shift. So then the resultant feedback voltage Vf is 180 degrees out of phase with the input signal. See this figure, observe this figure. This figure also consists of two components, two blocks, amplifier and feedback network. First of all, we can apply the input signal to the input of amplifier. So, apply positive going input signal is applied to the input of amplifier, but amplifier introduces 180 degrees phase shift. That's why this signal, this positive signal goes to negative signal. That is the output. That is the output of amplifier. This output of amplifier is fed back to the, given to the input of feedback network. Here feedback network introduces 0 degree phase shift. Feedback network introduces 0 degree phase shift. Then the negative signal is goes to output of feedback. Same signal goes to output of feedback network. Okay, this signal, output of feedback network signal is compared to input signal. So both are different. Input is positive going signal, so feedback network output is negative going signal. Both are different. That is, both are out of phase. Both are out of phase. Vf out of phase with Vin. So that's why both are not equal. That's why it is negative feedback. That's why it is negative feedback. Okay, positive feedback and negative feedback, very very important topic. Okay, these topics are completed. So introduction of feedback and oscillators and concept of feedback, and also positive feedback, negative feedback, all topics are clear. Okay, next, summary of this presentation. We have seen, understand the introduction, concept of feedback, positive feedback and negative feedback. Okay, these are completed. Next, frequently asked questions may be asked. Frequently asked questions may be asked. So define an oscillator. Define an oscillator. And second question may be asked, define feedback. Define feedback. Next, the third question may also be asked, define feedback factor. Define feedback factor. This question may also be asked, define feedback factor and write the equation for feedback factor. Okay. Next, fourth question, list the types of feedback in amplifiers. List the types of feedback in amplifiers. This question may also be asked, list the types of feedback and define the types. And define the types. Okay. Next, fifth question. Fifth question may also be asked, write short notes on positive and negative feedback. Write short notes on positive and negative feedback. This question may also be asked, draw the figure of positive feedback and negative feedback. Draw the figure of positive feedback and negative feedback. So different type of questions may be asked in today topics. Today topic is very very important topic. Okay. The definition of positive feedback and negative feedback are most important definitions. Okay, very very important concept or topics. Prepare well. Okay, thank you.